Hello, students. Welcome to the session Permutations under prerequisite to probability. In earlier sessions, we discussed about set theory. Okay, so before going for the probability, so we are supposed to know even permutations and combinations, because when you are doing the problems of probability, so definitely we'll come across many problems which are involving uh, the concepts of permutations and combinations. So we'll be discussing combinations concept in the next session. So meanwhile, we'll go for permutations. Okay, right. So again, before going for permutations, let us recollect what do you mean by factorial. So if you take n is any positive, we can say non-negative integer. So n is any non-negative integer means obviously it is nothing but, right? So n value non-negative integer, it may be 0, right, or 1, 2, 3, and so on. These are non-negative integers, right? These are non-negative integers. Now for these non-negative integers, if you want to know factorial, right, n factorial, I want to know what do you mean by n factorial. So what is the meaning of this? So we know that it is nothing but the product of the product of first product of n positive integers. So n factorial is nothing but 1, 2, 3 product I am taking till n. So product of first n positive integers. This is n factorial. But under the definition, 0 factorial is always defined as 1 factorial. 0 factorial is nothing but 1. 0 factorial is 1. And using this definition, now I can find out the remaining. Just like 1 factorial, it is 1. 2 factorial, it is nothing but 1 into 2, right? So like that, I can continue. Say maybe 3 factorial, it is nothing but 1 into 2 into 3. That is nothing but 6, of course. And here it is 1, this is 2, right? And 4 factorial is given by 1 into 2 into 3, right? Into 4. So that is nothing but 12. So like that, we can evaluate. And one more thing, you can observe that n factorial always can be written as n into n minus 1 factorial. It is easy to observe. And for example, if you take 5 factorial, I can write 5 factorial as 5 into 4 factorial. So which is nothing but 5 into 4 factorial is nothing but 12, right? So 4 factorial, okay, this is 24, I'm sorry, this is 24, right? 24, not 12. So this is 24. So 5 into 24 is nothing but 120. I'm sorry, 120, right? So like this, we can find out factorial concept, right? So just recollect this factorial concept, right? So now we move to the main concept, permutation, right? So remember that permutation is nothing but arrangements, right? So the both are equivalent words. So whenever we say arrangements, right? So you have to think that permutation concept we are going to implement, right? So what do you mean by that one? So generally we'll come across the problems where we need to arrange the objects. Arrangement means particularly in a row, right? Suppose generally we'll come across we need to arrange the books. We need to arrange the books in a shelf, right? Suppose we are having three textbook or five textbooks are, right? So one is mathematics textbook, physics, okay, chemistry, right? And we can say engineering mechanics, right? So assume that we are having four textbooks. Now you are having a shelf, okay? So we are having a shelf and you want to keep all these four books, right? So maybe first book, second book, third book, fourth book. You want to arrange them. You have to keep them in the shelf. Okay. So how many ways you can arrange them, or what are the possible ways you can arrange them? Right. You can arrange first. You can keep mathematics, physics, chemistry, right, and then maybe engineering mechanics, or otherwise we can keep M, P, E, C, or otherwise you can start with C, E, M, P, and so on. So there are some ways, there are different ways of how we can keep these four books in a shelf. Okay, so these are the meaning of arrangement. So arrangement means first keeping M, maths, physics, chemistry, English, or in engineering chemistry, I mean engineering mechanics, or maths, physics, engineering, mechanics, and chemistry, like that. So these are the nothing but called arrangements. These are arrangements, right? So similarly, we're having any three persons, A, B, C, and let me go for right. Just a minute. Okay, so right. So this is of, the first example of this one. right? Okay. Now, suppose you five students, okay, any five students, assume that five students, so went to a movie, okay, and you are a little bit late, and anyway, obviously you need to find five places to sit, okay, and you have found three chairs somewhere. We have found three chairs consecutively which are empty. Movie is almost houseful, and two more chairs are there in some other place. Suppose if you are having all five seats available, right? Because all five seats are available in a row, happily you can sit, right? How many possible ways? And you could suppose five students were having A, B, C, D, E. So five students are there. So just like this four, how you can arrange? So this is the possible ways you can sit here, right? But unfortunately, what happened? You are not having all five empty seats in a row. So three seats in one place and two seats in another place. So now, yeah, so five students, A, B, C, D, E, three seats are available, and in another place, two seats. Now, first of all, how many ways or what are the possible ways where three students of these five can be sit in these three places? Okay, so any three students. So three students out of these five has to be arranged in these three places. Three out of five. Okay, so 3 out of 5. So maybe I'll take ABC. For example, ABC first, they will come and they will try to sit. Okay, so what they will do? So first A, right? So A makes it, then B, then C. Or otherwise C, B, A, right? So there are different possibilities, B, A, C, like this. Okay, so or there is another possibility. Suppose first in these three places, C, D, E or B, C, D, they want to sit. So how they can sit? Again, B, C, D, B, D, C or C, D, B. So there are different ways. Okay, so out of five, of course, after three students sitting here, remaining two students obviously will sit in these two places. Now here the concept is what do you mean by arranging 3 from 5? 3 from 5, right? So that is what we are discussing. So if you take directly n objects, and how many, I mean, arranging n objects in a row is nothing but one permutation of arranging a permutation of the n objects in a row, permutation of n objects in a row. And the second concept what I am saying here is, so I have n objects. Out of n objects, I have to arrange r objects only. I have to arrange r objects, just like here, five students are there, but I am arranging only three, not five, only three. Okay, so this is called R permutation. Okay, R permutation, here it is mentioned. So it is called R permutation, or permutation of n objects taken R at a time. Permutation of n objects taken R at a time. Okay, so two concepts we are setting. All objects are arranged in a row, and here from these n objects, I am arranging only R objects, only R objects from n, not all n. Okay, so now anyway, so what are the, see, in these permutations we never come across what are the possible ways of arranging, what are the arrangements. We never ask what are the arrangements, but he will ask us how many ways are there to arrange, or how many permutations are there. That is what we'll ask, how many, right? So what are the arrangements, he never ask. Okay, so now we'll see what the formula for arranging of n objects in a row, arranging of n objects in a row, just like this, how many possibilities are there. Similarly, how many ways three students can be arranged from five, how many, so that we are going to find. Okay, so now the first one, what it shows, so there are n factorial permutations of n objects. It's very simple. So if you want to arrange n objects in a row, right? N objects in a row, or right, in a row, so that can be done in n factorial ways. So in the first example, what I told you, I have four books, right? And four books has to be arranged in a shelf. How many ways you can do? So there are 4 factorial ways. That is 24. So there are 24 ways where these are four books, right? Mathematics, physics, chemistry, engineering, mechanics, that can be arranged. First maths, second chemistry, like that. Totally 24 possibilities. So n objects can be arranged in a row in n factorial ways. Now similarly, what about this second one? So the number of permutations of n objects taken R at a time is denoted with P of n comma R. So that is P of n comma R. Okay, or otherwise another notation NPR. This is also another notation. Okay, And what is the formula for this P of n comma r or NPR? It is nothing but, so n factorial by n minus r factorial, right? N minus r factorial, right? So this is the formula, n factorial by n minus r factorial, right? Now, just now I have given one example. 5 students go to the movie, and 3 seats are there, and the 3 students out of 5 first they have to sit. So how many ways they can end? So exactly that is given by 5 p of 5 comma 3. So that is nothing but 5 factorial by 5 minus 3, which is 2 factorial. So this is 5, right? 4, 3, 2, 1. Okay, this is 2 into 1. So after simplification, okay, so this is going to be 60. Okay, this is going to be 60. So 60 ways are there where 3 students out of 5 they can sit in that place. 3, right? So this is the meaning. So two formula you have to remember. So one is n objects can be arranged in a row in n factorial ways, and another one is, right, so r objects can be arranged in a row from n objects. R objects can be arranged in a row from n objects in P of n comma r ways, right? So we collect these two. And right, suppose we take objects. So previous example, whatever the objects I have taken, they are distinct objects. Make a note, they are distinct. So 3 students, 5 students, see, these are all distinct objects. And the books also, what type books I have taken? They have taken different books. Okay, so physics, chemistry, maths, right? Engineering, mechanics, 5 different. Now suppose when you are arranging, we come across some situations where the some objects may be repeated. Okay, some objects may be repeated. For example, in a library, you'll go, you will be finding right, in a big row on a big shelf. Okay, so you'll be finding similar books. That is, for example, you take mathematics. Okay, same book, same author, everything same, that same copies, you will be finding so many copies. Okay, so how many ways you can arrange? For example, I have 3 physics books, okay, which are same author, exactly same copies, duplicates, right? 3. Okay, similarly 4 I have chemistry, 2 I have mathematics books. Okay, so it is just like P, 3 physics books, chemistry, 4 chemistry, and this. Now, how many ways you can arrange this total? How many books we are having totally? 9 books, right? So 9 books you have to arrange, but you cannot say 9 factorial. It will not work here. Okay, so if some books or some objects are repeating, in that case, I cannot say 9 factorial, just like previous one. Here it is different. So what is the formula here? So physics, totally how many first of all? So for totally we're having 9. So we'll take in numerator 9 factorial. In denominator, so first object is repeated 3 times. So we'll take 3 factorial. Second object is repeated 3 times again. Okay, 4 times, sorry. So chemistry books 4 factorial. Again 2 factorial. So simplify this many arrangements are there, okay, to which are these 3 physics, 4 chemistry, and 2 mathematics. So this is comes under permutations, okay, with the repetitions, permutations with the repetitions. So that concept we can discuss like that. Suppose there are n objects of which n1 are alike. So n1 of total n objects, n1 are alike, n2 are alike, nr are alike. That means similar objects are repeating, same number objects. So in that case, the number of permutations is given by n factorial. That is, total number is n by, and n factorial, n2 factorial, and so on, n1 n2 nr factorial. Right. So this is the way how we can. But this example cannot be discussed with the students like that, because students cannot be repeated. So there are only some, like maybe books or maybe balls. So suppose you take, I have few balls, right? Red color ball, white color ball, like that. So similar balls are there. How many ways you can arrange them means we can apply this one. Okay. So let us discuss a few problems. And here I have discussed 2 concepts. One is permutations, another one is permutations with repetitions. We are having some more concepts in permutations, which you will be discussing in discrete mathematics. And earlier also I told you that these permutations concept which you are discussing, it is quite helpful in your coding problems, right? So recollect that one. Now coming to these permutations, right? So yeah, so repetitions are sorry, if repetitions are not permitted, how many 3-digit numbers can be formed? Okay, from 6 digits, 2, 3, 5, 6, 7. Okay, so 3-digit numbers I want to form. So what are the numbers I have? I have 2, 3, 5, 6, 7, and 9. Okay, so I have totally 6 numbers. Okay, so how many 3-digit numbers can be from 6? So obviously this is P of 6 comma 3. So 3 digits, I want 3-digit numbers, maybe 235, 365, 796, like that. So how many I can form is 6, right? So that is a 6 factorial by 6 minus 3, which is 3 factorial. This is the first one. And little logical problems, right? So first of all, okay, total a big number we have. For example, if you want 6, 5, 4 into 3 factorial, I can write, and this is 3 factorial, both get cancels. So it is 30. So 30 means 120, right? We get 120, right? So 120 ways are there. Out we can arrange 3 from this one, right? And out of this 120, second question is asking how many of these are less than 400. So less than 400 means, okay, so I want to have the only less than 400. So that means when you take these 3 positions, first position must be filled with 2, 3. If it is 2, right, either 2 with 3, then only you will get the 3-digit number which is less than 400. So first position I can fill in 2 ways with 2, 3. And once you fill this one in 2 ways, and now I have leftover with 5. I have leftover with 5, right? So first one, 2 ways I can fill, either with 2 or 3. And once you fill with any 2 or 3, now I am left over with 5 digits, 2 positions. So how many ways you can do this one? Okay, so and 2 ways, this is first one, 2 ways, and 2 positions from 5, that can be done in P of 5 comma 2 ways. Okay, P of 5 comma 2 ways. So that is the way how you can do it, right? Okay, so this is the right second problem. Now second question, what this is the second one, and what is the third one is asking? So third one is asking how many are even number. So in these 3-digit numbers, okay, 3 digits numbers, when you take, how many are even number, right? So even number means we know the last digit must be even number. So this must be even. So how many even numbers are there? So we have 2, that is 6. 2 even numbers are there, 4 odd numbers. So 2 even numbers means I can fill this again 2 ways, right? So either with 2 or 6. Once you fill this one with the 2 or 6, okay, either you can fill with the 2 or 6, 2 ways, right? So now I have left over this one with 5 more numbers. So again 5 numbers, 2 positions are I am having, okay, and I have to fill this one with right, the same one will get. So P of 5 comma 2, P of 5 comma 2 is I can fill, right? So next to fourth one, if you check how many are odd numbers, say 3 numbers I have to pick up. Odd numbers, odd numbers means last one should be odd number, because any total big number is odd depending on the last digit. So we can fill this one in 4 ways. So 4 ways with 3, right? So 3, 5, 7, 9. 4 ways, 4 ways are there, okay? So this is 4 ways. And once 4 ways will fill one number, only one number will fill. Even though 4 possibilities are there, will fill only one number. And after that again have 5. So what is going to be there? So these 4 ways into remaining 2 digits can be filled from 5. Okay, sorry. Yeah. So again, P of 5 comma 2. So one number is filled, and last one, how many are multiples of 5? How many are multiples of 5? So multiples of 5 means last digit must be, okay, either 0 or 5. So but I do not have 0, so only 5 is there. So only 5 is there means I can fill this one in a one way, right? Only one way. 5 is fixed here, right? Multiple of number 5 with multiple of a 5 means last digit must be with 5 digit. So 5 can be filled in one way. Okay, so this number is filled, and now only one way. And what about the remaining two? Remaining two can be filled with 2, 3, 6, 7, 9, and that can be filled with again same. So 1 into P of 5 comma 2 ways, right? These are more logical one, right? Let me discuss about the next one, right? In a how many ways can a party of 7 persons arrange themselves in a row of 7 chairs? The first one is very simple. So we have a party, right? How many ways 7 persons can be arranged in a 7 rows, 7 chairs, 7 chairs in a row, 7 persons. How many ways they can? They obviously 7 factorial, right? And second one, so around a circular table, yes. Now try to understand that. So when you take a n, right, n objects can be arranged in a row of n positions in n factorial ways. And n objects you take, but n objects around a circular table, okay, round table. So this is one chair, this is another chair. So n persons are trying to sit around a table, right? Now, how many ways they can arrange around a table? So make a note. This is n minus 1 factorial. Okay. So clearly here it is going to be 7 persons around a table. Okay. So they can be arranged in 7 minus 1 factorial, which is 6 factorial. Right, ma? So this is another way. Right. So again, this is second type of this one. So he's taken one word, THEM. Okay, TH, I'll take capitals, THEM. So how many distinct permutations can be formed from these letters? THEM. So how many ways you can, so we had to arrange these 4 letters. THEM are 4 distinct letters. So how many ways you can, what are the distinct permutations or arrangements? Obviously arrangements. So all 4 are distinct. We can write in 4 factorial ways. But next one, unusual. Okay, right? This is the one. So how many U's are here? U's are here. Here it is repeating. 3 U's, 1 N, right? 1 S, right? And 3 U's, right? 1 N, right? 1 S, 1 A, 1 L, 1 A, and 1 L. So 3 objects are repeating. So when it is repeating, so we need to go for a slight different formula. But totally how many, right? We're having, so 7 letters are there, but not distinct. If they are distinct, just like them, THEM, 7 factorial, but they are not repeating. So you need to go for different formula. What is that formula? So total number of objects is 7 factorial, and one object is repeating 3 ways. So this is 3 factorial, and remaining is 1 factorial, 1 factorial, 1 factorial, 1 factorial. Of course, 1 factorial is 1, so we need not write it. Otherwise, we can say exactly 1 factorial whole to the power of 4, okay, which is obviously 1. So it is going to be 7 factorial by 3 factorial. That simplification you can do. Similarly, you can check this one. Okay, right. We'll move to the next one. So here is given. So there are 3 boys. Boys are 3 and girls are 2. In how many ways they can sit in a row? Okay. So 3 boys and totally how many? 5. So he's not putting any condition. 3 boys are there, 2 girls are there. So how many ways they can sit in a row? So totally 5. How many ways they can sit in a row means 5 factorial. Right. Now second one. In second one, in how many ways they can sit in a row if the boys and girls are sit together? So they have to sit together. That means boys should sit together and girls also sit together. So just like here 5 factorial, when you are discussing, for each one will keep a chair. Okay, 5 chairs. How many ways 5 can be sit in a row under 5 factorial? But here what we'll do, I'll take a just like a bench. Okay, in one bench all 3 boys will sit. Okay, in another bench 2 girls will sit. Okay, just like girls. So how many ways you can arrange them, right? So here you try to understand. First, for convenience, I have arranged the bench, not chairs, because all 3 should be together. These 2 also should be together. Together means who will sit first, boys or girls? Okay, 2 possibilities. Boys they may sit, or first girls and then boys. 3, right? These are the 2 ways. So 2 ways into, that means who will be sitting, either first boys or first girls, 2 ways. And again, inside or within themselves, how many ways 3 boys can be sit, right? So 3 boys, so that is done in a 3 factorial. And again 2 girls can sit in 2 positions in 2 factorial ways. So externally 2 ways they can be arranged, first boys, girls, or girls or boys. Or internally boys can be arranged in 3 factorial ways and girls can be arranged in 2 factorial ways. This is the total number. right? And the third one condition is giving that in how many ways can they sit in a row if just girls are sit together. Okay, so only girls should be together, right? Only girls should be together, but boys not necessary. So for boys we'll keep chairs, okay, like this. See, two boys may be right side, one boy may be left side, or two boys here, two girls, I mean two girls left side, right side, whatever, but two girls should be together. So totally how many items we have? So one, two, three, four items are there. Okay, four items or four chairs or four benches, totally four. So how many ways you can arrange all these? You can arrange them in a 4 factorial ways. And now externally, all these four can be arranged in 4 factorial ways. And what about within these two? So two girls, one left, one right, right? So that can be arranged in a 2 factorial ways. Okay. So externally, we can arrange them in 4 factorial. Internally, two girls can be arranged in 2 factorial. This is the number. So this is the way how we can discuss. Okay. So these are the simple basic concepts which you are supposed to know before going for probability from permutations, right? In the next section, we'll be discussing about combinations. Okay. Thank you all.